Today we can discuss about a dynamic programming algorithm, Needleman Wunsch algorithm, which we use to align two DNA or protein sequences. How we can align two sequences, a pair of sequences using Needleman Wunsch algorithm is what we are going to discuss. Before going to Needleman Wunsch algorithm, we should understand what is this dynamic programming algorithm is. What is this dynamic programming algorithm? Dynamic programming is a method that determines optimal alignment by matching two sequences for all possible pairs of characters between the two sequences. So, dynamic programming method usually calculate and find out the optimal alignment between two sequences. If you take two DNA sequences, they will try all possible alignments between these two sequences and find out the best optimal alignment between the two sequences by statistical methods. While it's earlier we used dot matrix method for finding the sequence alignment. Dot matrix method is more or less a qualitative method which is used to align the sequence DNA or protein sequence. We can see in the dot matrix method we will write the nucleotide sequences in a two-dimensional grid. We will write one set of sequence in one part of this grid, and other set of sequence in other part of this grid. We can see, and then qualitatively, it is a qualitative method to assess the alignment or alignment between the two sequences. Wherever we have a similarity, we will put a dot there, and here there is no similarity, so we are not putting the dot here. Here there is a similarity, we are putting a dot there. After putting this dots, we will find out the proper alignment using the how distribution of the dots in that matrix. So it is more or less a qualitative method, while we need a quantitative method method which has more statistically enriched one. We need to have such a method for aligning. So thus we came to the dynamic programming method. The dynamic programming method finds the alignment more quantitative way by converting a dot matrix into a scoring matrix to account for matches and mismatches between the sequence. In the case of dot matrix, we only account for the matches between the sequence. While in the case of this dynamic programming method, we will give some score for these mismatches also. We will give some score for the matches also. We will give some positive score for the matches. We will give some negative score for the mismatches. So we will score, and finally we will check all the scores, and we will check which is the highest score in this matrix, and from the highest score we will find out the alignment. This is about dynamic programming method. One of the most widely used dynamic programming algorithm is the Needleman Wunsch algorithm, which is this is what we are going to discuss in this video. So I will tell you how we can easily solve the Needleman Wunsch algorithm. It's a bit longer video. Please be patient. I am going through the basics as well as I will go through the matrix also. So once a method for scoring alignment is selected, an algorithm to find the best alignment or alignment between two sequences can be developed. So once the method of scoring alignment is selected, an algorithm to find the best alignment can be developed. Mainly, if we try to take one sequence and align with other, one sequence having a nucleotide number of nucleotides is 100, and other sequence having a number of nucleotides 95. As this is a smaller sequence, we will insert 5 gaps in the sequence so that it both become 100 nucleotide. If you try all the possible alignment between these two sequence of 100 and 95 nucleotide, we will get approximately 55 million type of alignment. and from this 55 million type of alignment, we need to select one which is the optimal alignment. How we can go and check all the 55 million possible alignments and find out a best alignment? It is not possible, it is impossible. So we will go for a mathematical method for calculating the alignment between these two sequences. How we can do that? To overcome this problem, we use dynamic programming. This method is the method of breaking a problem apart into reasonably sized sub problems. If there is a big problem, we will break up into sub problems. That is the dynamic programming method. Usually using the partial result to compute the final answer. Yes, Needleman and C. Wunsch were the first to apply the dynamic programming approach to the problem of sequence alignment, and their algorithm, which is similar to one which we are going to see, is one of the cornerstones of bioinformatics. That's why I am presenting this video also. If you are studying bioinformatics, you should study this Needleman Wunsch algorithm, because it is one of the cornerstones of bioinformatics. And you should understand how the dynamic programming algorithm, how we can fill the matrix, everything. So the key to understanding dynamic programming approach to sequence alignment lies in observing how the alignment is broken down into sub-problems. So the key in understanding the dynamic programming method is that we need to understand how the alignment problem is broken down. Suppose there is two sequences, one sequence of 5 nucleotide and one sequence of 3 nucleotide. Assume now that we are using uniform gaps and mismatch penalties. So when we align these two sequences, there will be, you need to keep in mind, there will be 3 possibilities on when we are aligning two sequences. One of the possibility is that we can place a gap in the first sequence. We can place a gap in the first sequence. We can place some gap in the first sequence. I will show like this only. We can place a gap in the first sequence, or else we can place a gap in the second sequence. Usually the longer sequence we don't place a gap usually, and we can anyway this is a rule of the algorithm. We can place a gap in the upper sequence, or we can place a gap in the lower sequence, or else without any gap, inserting gap, we can score the alignment, because if we score the alignment, we can score the alignment based on the match and mismatch between the two sequences. In the first two cases, the alignment score at the first position, if we insert the gap in the first two cases, we can see the first two positions, first two cases, the alignment score of first position will be equal to gap penalty. So we are inserting a gap in the first position. The gap is inserted in the first position, not the last position. Inserted in the first position. Usually the scores between alignment scores of the first position will be a gap penalty. While if you try to align the third condition, the last case, the alignment score of the first position will be equal to the match bonus. When we try to align these two sequences, without a gap, how it will be, I will show you. Without a gap means we will try to align. This is one sequence. Where is my? This is the other sequence. C, G, A. So here we can see the first sequence. This will be a match bonus. So we can see the first two cases. The score will be only a gap penalty, while if without inserting gap, we got a match bonus or match score in this third cases. So again, rest score will depends on how to align. So we are only calculated the first score. Based on these 3 parameters only, we are going to fill the matrix. That is why we are just introducing how to fill the matrix. That is why we are discussed about inserting gap in the first position, inserting gap in the first position of the first sequence, inserting gap in the first position of the second sequence, or else without inserting gap, we will check for the match or mismatch penalty. That is what we are looking for in this programming algorithm. While coming to the dynamic programming algorithm, we here is this is the dynamic program Needleman Wunsch algorithm. This score chart you can see here. We are trying to align these two sequences. Okay. The dynamic programming algorithm computes optimal sequence alignment by filling in the table of partial sequence alignment alignment scores until the scores of the entire sequence alignment has been calculated. So we are trying to fill this table of partial sequence alignment. We are aligning these two sequences. How to align these two sequences? For aligning these two sequences, we should algorithm utilize a table in which horizontal and vertical axis is able with two sequences. So the horizontal as well as the vertical axis, we will write the two sequences which need to be aligned first. This is the first thing you need to do. Okay, and then we can see usually when we go for an alignment, and then this second process I will go to the next process and then I will come to the text. Next process is you need to initialize this rows and columns with the multiples of match penalty. I have not said about the not match penalty, gap penalty, sorry. So gap penalty. So I have not shown you what is gap penalty, everything. We can see the gap penalty in this score table. We are giving gap penalty as -1, match bonuses +1, and mismatch score as 0. The scores which we are going to give in this Needleman Wunsch algorithm is gap penalty -1, match bonus +1, and mismatch score 0. The first thing we need to do is we will write the multiples of gap penalty in these rows and column. This is the first thing you need. First thing you need to write the sequences. Then you need to write the multiples of the gap penalty as -1, -2, etc. Then how to fill this table? That is what we are going to check. We usually fill this table row by row. We usually fill this table row by row. We can't go any other path, row by row. We need to fill this row, then only we can go to this row. Like that, row by row, we will fill this table. So how to fill this table? I will just go out and come because my table is so much figures, everything is there. So how to fill this table? We have already seen there are three possibilities when filling this table. One is a mismatch, a gap in the upper sequence. We can consider here a gap, or a gap in the lower sequence, or a match or mismatch penalty. That is what we are going to use in filling this table. So gap penalty is how much? -1. So what we need to do is that gap in the upper table means we need to look at, we are going to fill this space. How to fill this space? We will look the upper tab of above this space to be filled. In this tab, it is written as -1. To this -1, we will add the gap penalty, that is the -1. Because we to the upper tab as well as to the side tab, we will add the gap penalty. Here also we will add -1. And then we will take the third tab which is related to this position we need to fill, that is a diagonal one. Diagonal one, it is written as 0. And then we will look whether this A and A is matching or not. This A and this A is matching or not. Yes, it is matching. If it is matching, the match, how much is the match bonus? +1. We will add this +1 to the 0. So we got 3 values. In the upper portion, we will got the value -2. In the side portion, we got the value -2. In the diagonal portion, we got the value 1. And in these 3, which one is the bigger one? The 1 is the bigger. So we will fill the one here. So next we need to fill this tab. How to fill this tab? We will add -1 to this side upper tab. So -2 plus -1 is equal to -3. We can see the -3 here, and then we will add -1 to the side tab. 1 plus -1 is equal to 0. We can see the tab is 0, and here -1. Here we will add the diagonal one. It is mismatched. C and A is mismatching. So -1 plus 0. Mismatch penalty is 0. So -1. So we have 3 values. Which one is the highest one? 0 is the highest one. So we will fill here 0. Likewise, we will fill each rows like this. This way we will fill the each rows. That is what they are telling all this here. So that is how we are going to fill the all things which they have mentioned is like that only. We can see how it is filled, how to fill the table. We can see like that only they are filled. We need to look on these three areas when we are filling this one. So we need to add the gap penalty with here, and the gap penalty with here, match or mismatch. Here it is A and A match, so we will add the match penalty 1. If it is A, if it is G, we will add the mismatch penalty, that is 0. So it becomes 0. So we can write it here 0. Like that, we can fill the whole Needleman Wunsch score table. After filling this table, we will go to the lowermost portion of the table. We can see the lowermost portion, the highest number ends in lowermost portion is 2. From there, we can go diagonally to build up the alignment so that it becomes 0. And then we need to move sometime vertically above, and then again go to the diagonally and reach finally the point which we start. We will start from the lowermost corner to the uppermost part where we start. Here if it is very much similar sequence, we should have get a proper diagonal. But here we got 2 vertical movement. If 2 vertical movement is there, we can say there will be 2 gaps in the upper sequence. If the move may be horizontal, we can say there will be gaps in the side sequence. If the vertical movement is there, we can say the gap will be in the topmost sequence. Horizontal movement will be there, we can say the gap will be in the side sequence. So we can finally write the alignment. So first we have seen the 2 here. So the G and G is the one which present in here. So we will align the G and G first, and then we can go to the next arrows. Here here we can see here the Z and A is aligned, and then T and T is aligned. We can see here T and T is aligned, and then we will reach that 0 position where a horizontal move is there. So here is a horizontal move is there. So G and a gap will be aligned. G and a gap will be aligned. So because the topmost sequence we can see 2 gaps because of that vertical movement, and further the movement more diagonally we can see the aligning between A and A and C and C alignment we can see. So that is what we got the alignment using the Needleman Wunsch algorithm. If this is very simple algorithm, don't be confused with anything. We only need to look at these 3 points why we are looking at this algorithm. So many people will be confused with this, that's why I am doing it. I hope it is more simpler to solve this score table. If you have any more doubt, you can just comment on this comment line of this video. Thank you for watching my video. If you are finding interested in my talks, please subscribe to my channel. Thank you.